Hey, y'all, let's cover exam one. I'm just going to go over this with you real quick. If you have any questions over what you did on it, please let me know. I'm going to try to scan those back in this week and get those to you. Please make sure you go through this video with your exam so that you can see where the myth was. I can tell you for the most part, pretty much everyone missed reading directions. And this is my goal, is for you to learn to take a test, and to take a test, you need to learn to read directions. So for this exam, you're allowed to use one 3x5 note card or calculator. Great. Please show all your work. Breathe. Do your best. Read all problems first. If you don't remember how to solve problems, skip it and come back to it. Don't get stuck on one problem. Remember to answer in sentence form. This gives you the directions on what my expectations are in sentence form, and correct units when necessary. Here's the piece that you missed. To get an extra 2 points, put the month you were born by your name above. So you could have gotten an extra 2 points just by putting by your name the month you were born. Okay, but you missed that. So hate that. Read the directions next time. So opportunity. Consider, okay, I also gave you a formula for an area of a rectangle. Many of you did not use that whenever you went through and worked the problems. This is the formula you needed, and you just didn't use it. So don't know what to answer there. Consider the number 496,042,051. Write the digit for the given place value in the whole number. So 10,000. So ones, tens, hundreds, thousands. 10,000s is the 4. Hundreds is 0. And millions is 6. Right? It's ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions. Write the number using the digits. 903 million. 903. 701,701. 27. 27. Identify the numbers labeled with the letters A, B, and C on the scale. So we're looking for this one, and this one. What we see from here to here is 1,000. So half of 1,000 is 500. All right, so that's 6,500. And then half of that would be 6,250, because half of 500 is 250. So each one of these hash marks are worth 250. So that means this would be 7,250. This would be 7,500. So B is 7,500. A is 6,250, 6,250. And C, well, if this is 6,000, this has to be 5,000, and you're going to have to subtract 250 from 6,000, which would be 750, 750. So 5,750. Okay. Tyler decides he needs a new computer. The cost of the computer is $800. However, the store also offers a rent-to-own option, which will cost $50 per week for 24 weeks. How much will Tyler pay to rent-to-own? Well, that's just the cost of it per week for the amount of weeks. So that's $50 times 24. I'm just going to do it here instead of a calculator. So $1,200 is how much he would pay for rent-to-own. So again, I have to answer in sentence form. Tyler will pay, don't forget your unit, $1,200 for rent-to-own. How much more will the rent-to-own option cost after he's made all of his payments? Well, if rent-to-own is $1,200, we need to find out the difference between that and the $800 for the cost of the computer to see how much more he's paying. And that's $400. So Tyler will pay okay, but let's say it's just how much more. Okay, we'll just say pay $400 more. or rent to own. Okay. Thomas created a yard in his backyard for the shape of the figure given. He wants to put a fence around the yard. How much fencing does he need to buy? So if he wants a fence to go all the way around, I cannot draw, just assume that this is going around this figure, then we need to know what every single side of this figure is. We know this side, and these two. So we need to know what these two sides are. In order to find those, we need to look at something that's comparable. Well, if this line continued all the way over here, it would be 17 feet, but it doesn't. What's it missing? It's missing 5 feet. So this would be 17 minus 5, which is 12 feet. That's what this one is. All right. This one, if it continued all the way down, would be 12 feet, but it's missing the 4 feet. So this is just 12 minus 4, which is 8 feet. Okay, now we know all the sides and we can add them all up. Just need to find what I want to start with. So 17, 12, 5, 8, 12, and 4. Just add these up. 8, 2, 3, 4, and 5. So how much fencing does he need to buy? He needs to buy at least 58 feet of fencing. All right, so when I answer this, a complete sentence, I've got rounding, there's no rounding needed, and then my unit is feet, so I'm good to go. The next one is Amanda suggested that Thomas put a cover over the yard to protect his family from the sun. How much fabric is needed for the cover? And I even told you what to use, find the area of the given figure. So you just need to break this down into two, and it doesn't matter which two rectangles you create, you just need 2 rectangles so that you can find the area. And I like to label them A1 and A2, just so that I know what I'm looking for. So A1 and A2, and I told you at the beginning, that's length times width for a rectangle. So if we have 12 and 5, that can be 12 times 5 for area 1, which is 60. And then area 2 would be this piece, which is 12, and this piece, which is 4. 12 times 4 is 48. So we need to add those to get the area for the entire thing. So to add those, that would be 8 and 108. How much fabric is needed for the cover? He needs 108 square feet, or feet squared. I don't care how you write it. I'm going to write square feet. You could write feet squared. The main thing is that you've got to get that square, because every time area is always measured in squares. And this is going to be carrying through to your next class as well. So he needs 108 square feet of fabric. For my answer, I just need to check back. I've got a sentence, I don't have to worry about rounding, and then I've got my correct units. So I'm good to go. All right. Eric is driving 2,223 miles on a road trip from JCC to Vegas to see the Super Bowl. If he takes his time and drives 247 miles a day, how many days will it take to complete the trip? Well, this is just taking the miles and dividing by however many miles he's going per day. So if he's going 2,223 miles, then he needs to divide it by however many he's going per day. And he's going, oops, sorry about that. Let me get rid of this. Don't need that distraction. 2,223, 1, 2, 3 there, divided by 247 miles. He's going to take 9 days. How many days will it take to complete the trip? It will take, I'm just answering, it will take 9 days. And I can just stop right there, or I could say to complete the trip. All right, find the prime factorization of 198. Oh, y'all, excuse me 1 second, please. Okay, sorry about that. So for prime factorization, that just means taking the number and breaking it down to only prime numbers. So the first thing I see is it ends in an 8. I know it's divisible by 2. But if I add the digits also, 9, 10, 10 plus 8 is 18. 18 is divisible by 3. So I know that 3 goes into it as well. But I'm just going to go with what my original was, which was 2 and 99. All right. 2 times 99 is 198. 2 is prime, so that one's done. I need to break down 99 until it's prime numbers. I know my 11s. 11 times 9 is 99. So 9 and 11. 11 is prime. I need to factor the 9 because it's still made up of 2 different numbers besides 9 and 1. And that is 3 and 3, and those are both prime. So for the prime factorization, 198, I could say 2 times 3 times 3 times 11. That could have been your answer. Or you could have said 198, 2 times 3 squared times 11. I would have accepted either one of those because we covered them both in our lecture. Enter all the factors of 198. Well, that's just taking all of these numbers and finding out what can go into it. We know that 1, 2, 3, 3 times 2 is 6. What else? 3 times 3 is 9. And then we've got 11. I'm just trying to go in order. 11 times, well, I could also do 9 times 2 is 18. 18. 11 times 2 is 22. 11 times 3 is 33. Then I could do 6 times 11 is 66. I could do 9 times 11 is 99. And then I could have the 198. There are all the factors of 198. Given these numbers, which of these numbers are composite? Prove your answer. Composite is just where more than just the number and itself will go into the number. So prime is where the only things that you can factor the number from is 1 in itself. So there's only a couple of those. We have to prove the ones that are composite to prove they're not prime. So starting with 91. 91, it's not going to be divisible by 3. So it's not divisible by 2 or 5. So not 4, not 6. Let's try 7. 91 divided by 7 is 13. Well, there you go. 7 times 13. All right, 51. I know that one's not prime because 5 plus 1 is 6, and 6 is divisible by 3. So I know 3 goes into 51. So 51 divided by 3 is 17. I just need to prove one set of numbers that aren't 1 in itself. 121 I know is 11 times 11. 41 is prime. There is nothing that can go into that. 87 is not prime. What was the 8 plus 7 is 15. 15 is divisible by 3. So 87 is divisible by 3, and it's 29. And then 53 is prime. Nothing else will go into it besides 1 in itself. All right. Simplify. All right, we've got 1 plus 1 times 2. This simple little problem really hurts some of y'all. If you think of PEMDAS, you cannot forget this guy. You have to deal with parentheses and exponents. We don't have that. Multiplication comes before addition. You have to multiply these two numbers before you add the 1. So this is 1 plus 1 times 2 is 2. 1 plus 2 is 3. So many of you did 1 plus 1 is 2 times 2. That's so wrong. You have to do multiplication before you do addition. The next one, you have to do parentheses before you do anything. So this is 2 plus 3 times 8 minus 3. They're different, so we have to subtract them. So that's 5. Now we have multiplication and addition. Multiplication comes before addition. So this is 2 plus 3 times 5 is 15. And then the last one is 2 plus 15 is 17. All right, this one has a lot going on. We have no parentheses, but we do have an exponent. We need to do that exponent first. because order of operations, exponents come before everything else besides parentheses. So I'm just going to bring everything else down. Times, and this is 2 cubed. 2 cubed is just 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. Okay. Now the next thing, I've got addition, division, addition, multiplication. So multiplication, division come before the addition. But I have to work the multiplication division from left to right. So I can't do anything with the 4 because it's added. 10 divided by 2, I have to do that first. 5. Plus, and now I can do the 1 times 8 is 8. Now everything is added, so I can just add straight across. 9 plus 8 is 17. I was not trying to trick you by giving you the same answers. Just happened. All right, never trying to trick you. My goal is just to make sure you understand how to do this. So solve for x. X plus 5 is equal to 19. All right, so who's attached to x and how? 5 is attached to x by addition. So we have to do the opposite of addition or the inverse of addition. And what you do to one side, you do to the other. So that we can just get x isolated on its one side. 5 minus 5 is 0, so that's gone. And 19 minus 5 is 14. You can check this. Just taking your x plus 5 is equal to 19 and plugging in 14 for your x that you just solved for. Just make sure both sides equal each other, and when they do, you're golden. Let's look at the next one. X minus 3 is equal to 8. Who's attached to x and how? 3 is attached by subtraction. So the opposite or inverse of subtraction is addition. Therefore, we have to add 3. We do to one side, we do to the other. We bring down the x. This is now 0 is equal to 8 plus 3 is 8 is 11. Again, let's check ourselves. I'm going to take the x minus 3 is equal to 8. Plug in the 11 I got and make sure they equal. And they do. So we're good. All right. Oh, this is a fun one. 2 plus 2 times 5 minus 3 cubed minus 3 times 9 minus 7 squared. Again, I'm going to put my order of operations up here so I remember what to do. All right, parentheses first. So I have to hit both of these parentheses first. 2 plus 2 times. Just going to do this so that I know that I'm dealing with my parentheses. 5 minus 3 is 2. 9 minus 7 is 2. All right. I've done my parentheses. Now I have to do my exponents. So 2 cubed is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 2 squared is 2 times 2, which is 4. Okay. Parentheses, check. Exponents, check. Now we have multiplication and division. This is addition. Oh, this is multiplication. 2 times 8 is 16. And I'm going left to right, so I can do this. Minus 3 times 4 is 12. Okay. Left to right for addition and subtraction. 2 plus 16 is 18. Minus 12 is 6. Let me know what questions you have. Find the area of the rectangle below. I gave you the area of the rectangle at the beginning. It's just length times width. So area is 8 times 5. That's 40. I need to give this in a sentence. The area, because question is, area is 40. I need to have my correct units. Centimeters, because area is always measured in squares. I can write that, or I can write square centimeters. All right, Joanna said 9 more than twice a number, certain number is 31. What is Joanna referring to? So 9 more than twice a certain number. So if something is more than, if I have an apple and I say Joanna has 3 more apples, 3 more, how can I say this? 3 more than me, then that's taking what I have and adding 3. So that's taking what I have and adding 9. Okay. Twice a certain number. Well, twice, we need to have a vocabulary here. So a certain number, this certain number or is We're gonna call it X. All right, so that's 2 times X. So 2 times X plus 9, and is always equals. Language is equals 31. So there is my equation. Now I just need to solve for X. 9 is added to this, so I need to subtract 9 from both sides. And I get 2x is equal to, I think that's, what is that, 28? 22. And then divide both sides by 2. And x equals 11. So, Joanna's number, the certain number, is, or you could write Joanna is referring to 11. There's no units or rounding. Bonus on the last page. So that was just bonuses for you to add extra points to your grade. Please always do the bonus, even if you think it's just not important. Why would you leave money on the table? Don't do it. Let me know what questions y'all have.